Next example we want to work here is we want to solve the equation exactly using a double angle formula. And so with this problem here, you can see that we are starting with cosine of 2 theta equal to theta. So let's just remember out here to the side, cosine of 2 theta, one of the double angle formulas we can use for this one, is 2 cosine squared theta minus 1. My hope is in using this one, I can get into singular cosine thetas, move them all around, solve it like we did in some previous problems, almost like a quadratic. So this gives me 2 cosine squared theta minus cosine theta equal minus 1, equal to 0. And so I'm going to make a variable substitution. Say let's let x equal cosine theta, so it gives me 2x squared minus x equal to 1. Which is great. This will factor into 2x plus 1 and x minus 1 equal to 0. Solve this out. And I get negative 1/2 and 1. But again, we are working with cosine theta. And so I'm going to say let's let cosine theta equal to negative 1/2. So if you go back to your trig circle, this gives me theta equal to 2 pi over 3. And we're going to let cosine theta equal 1. And this gives me the value of theta being equal to 0. Now, this doesn't give us any domain restriction or theta restrictions. Just even in this next problem right below it, you can see that it's restricted, it's theta. This one has not. So we're going to have to apply the periods into this one. So we're going to say plus 2 pi k plus 2 pi k in order to find all the angles that would solve this equation. Now, if they have given us some restrictions, we would have to add that in, but because we did not, we need to add in that plus 2 pi k onto both of those answers. Now, in this next one, let's notice this. It says solve the equation exactly using an identity, and they give us 3 cosine theta plus 3 equal to 2 sine squared theta. And they do restrict our theta in this one. So the key with this one is I've got sines and cosines. So I would really prefer if I could get all to a singular trig function, and then maybe it would follow suit of our previous problems. And so I'm going to apply an identity here of sine squared equal to 1 minus cosine squared. So bring everything else down. 3 cosine theta plus 3 equal to 2 times 1 minus cosine squared, using my Pythagorean identity there. I'm going to distribute. And then I'm going to move everything over to one side. So I'm going to move everything over here to the left. So it gives me 2 cosine squared, plus 3 cosine theta. Subtract the 2 over, and that would give me a plus 1 equal to 0. Now another substitution I'm going to make is I'm going to change over variables here. So I get 2x squared plus 3x plus 1 equal to 0. When I factor this out, it gives me 2x plus 1, x plus 1 equal to 0. And then solve accordingly. And so the two answers that I get is I get x equal to negative 1/2 and x equal to negative 1. And again, we made a variable substitution. So this means I have cosine theta is equal to negative 1/2. And that occurs, trig circle, 2 pi over 3 and 4 pi over 3. And I also have cosine theta equal to negative 1. And that happens at pi. Now with this problem, since it was restricted between 0 and 2 pi, these will be the 3 answers that I get, and I don't have to add on the periods of 2 pi. Now on number 6 here, what we're going to be looking at is we're going to be looking at solving some trig equations with multiple angles. So it says solve exactly cosine 2x equal to 1/2, and we are on the interval from 0 to 2 pi. So let's consider this. 1/2 looks really familiar, and so if this had not been 2x, just kind of like that's not there, if it had just been cosine of something equal to 1/2, I could go to my unit circle. And so I can't forget about this. but I am going to think about my trig circle and think, you know, where does cosine of an angle equal 1/2? And according to our unit circle, that occurs when we're at pi over 3 and 5 pi over 3. So instead of 2x, I have a theta, so let's just do that. Let's let theta equal 2x. And actually, let me work with what that was equal to. We know that both of those angles are here. And so I'm going to be looking at 2x being equal to pi over 3. If I divide both sides by 2, that gives me x to be pi over 6. Now, I also need to set 2x equal to 5 pi over 3. Again, dividing by 2, this would give me 5 pi over 6. Now, I need to make sure I get all the angles between 0 and 2 pi. So what I'm going to do is I'm going to cycle up. And I'm going to take pi over 3. I'm going to add 2 pi to it. And just make sure that when I add in, and when I start moving that 2x around, that it does give me something still between 0 and 2 pi, or if it cycles out. So when you add all that together and then solve it out, this actually gives me x to be 7 pi over 6, which is between 0 and 2 pi. So there's the third answer. When I add 2 pi to the 5 pi over 6, that one does not work out. It does not fit in between there. Actually, let's just write that one down there. Spoke too soon. Add my 2 pi, and so this actually does give me 11 pi over 3. And so this actually gives me 4 different values between 0 and 2 pi that are going to work nicely for me. So just remember as you're working through these that you always need to cycle through as many times as you can to get up to it. You could have tried 4 pi the next cycle over just because you are doubling that angle up, but when you add in 4 pi to pi over 3 and 5 pi over 3, it does not pan out. There's a nice little thing that they say. They say if you're working with sine of nx equal to some value c, that you need to check your unit circle n times. And so like for us, ours would be 2, so we would need to check our unit circle 2 times, but as I just stated, when you check those 2 smaller angles in relation to 4 pi, you do get out of your domain of being between 0 and 2 pi. So just make sure you get all of the solutions within there. Now for part 7 here, we're going to be looking at solving some problems here, and so I've kind of put a little bit more information in on these. It says use Pythagorean theorem and the properties of right triangles to model an equation that fits. One of the cables that anchors the center of the London Eye Ferris wheel to the ground must be replaced. The center of the Ferris wheel is 69.5 meters above the ground. So you can see here in a picture, here's our 69.5. And the second anchor on the ground is 23 meters from the base of the Ferris wheel. So we actually get this value as well. Approximately how long is the cable and what is the angle of elevation from the ground up to the center of the Ferris wheel? Well, when I'm faced with a right triangle problem, I immediately think of a squared plus b squared equal to c squared. And so I'm going to say 23 squared plus 69.5 squared equals c squared. Calculate, calculate, and you should get c to be 73.2. So first question, how long is the cable? It's about 73.2 meters. Then it says find the angle of elevation. Well, I have all 3 sides of the triangle, and so I can really use any of my 6 trig functions that I would like, but I am going to use tangent with this one, because if you think about SOHCAHTOA and think about tangent, this would be opposite over adjacent. And opposite would be 69.5, adjacent would be 23, and so I would not be messing with my calculation. So if it was a 2-part problem, I don't have to go, man, I hope I got 73.2 right. If I didn't, it's going to mess up the next part. At least I would get the second part right because I'm using given values. So I always like to go back to given values, or in this case, exact values, because the 73.2 was a rounded number. And so in order to solve for theta, I'm going to have to use arctangent. So I'm going to say arctangent of 69.5 over 23. Definitely going to have to use my calculator on this one. And in order of radians, this would be 1.2522. Or if you want it degrees, change the mode on your calculator. It'd be 71.7 degrees. And so it says, and what's the angle of elevation? That would be this angle here, and it is 71.7 degrees. Now let's do another kind of application problem here, a little bit more than just looking at the equations. This one says OSHA's safety regulations require that the base of a ladder be placed 1 foot from the wall for every 4 foot of ladder length. Find the angle that a ladder of any length forms with the ground and the height at which the ladder touches the wall. And so here's my wall. Draw you a nice little wall there. And then here's our ladder. So you can see the concept here. I always like to kind of draw a realistic picture. That one's kind of horrible. And then a geometric picture. So geometrically, we're looking at a triangle. And it's saying that the base of a ladder is to be placed 1 foot from the wall for every 4 foot of ladder length. And so let's say this. If this is A, how far I am from the wall, it means my ladder would be 4 times that value. So if it was a 4 foot ladder, I'd be 1 foot from the wall. If it was a 8 foot ladder, I'd have to be 2 foot from the wall, etc. And I'm just going to call this B, just to call it something else here. So if I consider this, it says find the angle that we're looking at here. I want to kind of relate things. And again, I've got all 3 sides. I'm calling them A's and B's and 4A's, but I do have all 3 sides. I am going to use one that purposely relates the letters that are the same, hopefully to maybe reduce those. So if I think about this, from this angle here, this would be my adjacent and my hypotenuse. So that would be SOCA. So it would be your cosine that is equal to your adjacent over hypotenuse. So cosine of theta would be equal to my adjacent, which is A, over my hypotenuse, which is 4A, which is great because you can see those A's would cancel. So I end up with cosine of theta is equal to 1/4. So if I say theta is equal to arc cosine of 1/4, I can easily get this angle out to be, and I'll stay in degrees with this one, 75.5 degrees. So it said, find the angle that a ladder of a length forms with the ground. There it is. And it doesn't matter the length of the ladder. It's going to be proportional because we know as our ladder is getting longer, the distance from the wall is going to get longer. So we're going to have a good proportion there. Now we need to find the height at which the ladder touches the wall. It's not asking the height of the ladder. It's asking the proportional height of when it touches the wall. Well, that's still a right triangle over here. And so I'm going to say A squared plus B squared is equal to 4A squared. And just be careful that you do put parentheses around this. A squared plus B squared is equal to 16A squared. Solving for B, I'm trying to find the height at which the ladder touches the wall. So I'm trying to find how far up the wall it is. So I'm going to subtract this A squared over here. And so it gives me 15A squared square root. So B is equal to the square root of 15A. So once you tell me A, I can figure out the rest of this problem and what it lies. So I hope this helps with 9.5. Again, as always, if you have any questions along the way, just send me a message. I'll be happy to help you out with these problems.